Guys, our next video is going to talk about how we graph trig functions using transformations. We graph the parent functions in the first part. Here we're going to add in some numbers being multiplied in front, some a values, a b value, a c value, a d value. We're going to talk about what we need to do to graph these trig functions. So we break it down really into three steps. The first step being the easiest. We're going to find the three y values. Okay, we will mandate that you give us three y values, just like on the parent function. So for sine, cosine, and tangent, those y values were -1, 0, and 1. Okay? And two of these, the a value and the d value, if they're there, those are going to affect the y values. They're affected by a and d. Okay? A is really the vertical stretch. It could be classified as the amplitude. Remember, we use the word amplitude with just sine and cosine graphs. The d, that's the vertical shift. Okay, so how are we going to do this? We're going to use the vertical shift, or the d value, to find the middle y value. And then we're going to use the a value to find the top and bottom by adding or subtracting from D, or the middle of the wave. Okay, so let's just start with step one here, the y values, on an actual example, and then we'll get back to the couple other steps to this. So I'm going to turn the page. Okay, and as you can see, instead of just sine of x, we now have all of this along with it. Okay, if we're looking for the y values, again, we're going to use the a and the d, and we're going to follow along with the steps. Okay, so normally the normal y values of the parent function are -1, 0, and 1. Okay, so our first step was to take the vertical shift, which I've added here a +3 because I wanted to talk about vertical shift. Okay, we're going to add this to the 0 to find the middle of our wave. So the middle y value will be 3. Okay. Normally the amplitude, or the vertical stretch, is a 1. The distance between 0 and 1 is 1, 0 and -1 is 1. Now our a value is 2. So we're going to have a distance of 2 from our new middle of 3 to both the top and the bottom. If we add 2 to 3, we get 5. If we subtract 2 from 3, we get 1. And really the easiest part of graphing trig functions, hopefully for you guys, will be the three y values. Hopefully we're in good shape with that. Okay? Now, we need to find the 5 x values. Just like in the parent function, we're going to use 5 angle measures, 5 radian measures, as our x values. Normally 0 to 2 pi, and the angles in between, pi over 2, pi, 3 pi over 2, and so on. Okay, so this will be affected by the b and the c in our general trig function. The number multiplied out front of the quantity, and the number added or subtracted within the quantity. Okay, first thing we're going to do is we're going to use the c value, which is our horizontal shift, to move the 0 value. Okay. So normally we have a point that's at x equals 0 on the parent function of all of our trig functions, sine, cosine, and tangent. we're going to use our horizontal shift to move that. Okay, just like you used to with root functions and cubics and parabolas. A plus or a minus is going to move it either right or left. We need to remember that a positive c is going to move it to the left, and a negative c is going to move it to the right. That can be confusing for students. Okay? And then secondly, we're going to use the period to find the end of our one cycle for sine and cosine graphs. Okay. For tangent, well, we'll get into that in just a little bit. All right. So let's use the c value, let's use our period. How do we find the period? Our parent function has a period of 2 pi. Okay, for sine and cosine, our period will equal 2 pi divided by the b value. Okay, that's why b and c affect the x values of our one cycle. Okay, might be a little confusing here. Hopefully you will see that it's not so confusing when we do this example. Okay, so let's turn the page. Okay, I know we're going quickly, but we'll get plenty of practice with this over the next couple weeks. You guys will be experts in trig graphing. All right, here's our b, here's our c. We have a positive c value. This means we have a horizontal shift of left pi. So normally we start our one cycle at 0, left pi. We're now going to start our one cycle at negative pi. If we move 0 to the left pi, we're at negative pi. Okay? Now we need to figure out our period. Our period is 2 pi, which is our normal parent function period of sine, divided by the b value. The b value is 2. 2 pi divided by 2. Our period is pi. Remember that the period is defined as the distance that it takes for the graph to make one cycle, or if you want to think about it like I do, the distance between the start and the end of one cycle. If we're going to start at negative pi and end at a distance of pi, if you want to add these, that's fine. Negative pi plus pi. We're going to end one cycle at 0. So we've got our starting point, if you will, our ending point, if you will. We use the horizontal shift to find the starting point, left pi. We use the period to find the end of one cycle. How do we find our 3 middle x values that we'll ask you for when you graph? We just take the averages. The average, or the middle, of negative pi and 0 would be negative pi over 2. The value in between negative pi over 2 and 0 would be negative pi over 4. The number in between negative pi and negative pi over 2 is negative 3 pi over 4. Okay? Remember, we can find averages by adding them up and dividing by 2. That's fine. Notice that each of these intervals is pi over 4 apart. One other way of graphing the x values is taking 1/4 of the period and finding your intervals that way. So taking negative pi, adding pi over 4, adding pi over 4, adding pi over 4, adding pi over 4, because that's 1/4 of the period. Not necessarily how we teach it, but it's something that can be done as you're picking up on the patterns here. Okay? We have our 3y values, we have our 5x values. The last step, we'll get back to tangent a little bit later. Our last step is to graph using the shape of the parent function. Okay? So our parent functions, let's recap. We have sine, we have cosine, and we'll deal with tangent a little later. So sine, 3x values, 5y values. Starts in the middle of the wave, up, middle, bottom, middle. For cosine, we have 3 y values, we have 5 x values. Cosine starts at the top, middle, bottom, middle, top. Okay. A negative sign in front of these would be a reflection. If the a value is negative, it would reflect sign. It would go middle, bottom, middle, top, bottom. So the dashed line is the reflected sine graph. Cosine, if it had a negative a value, would start at the bottom, middle, top, middle, bottom. And again, the dashed is the reflected. Okay? So a negative a value equals a reflection. Okay? Let's check out the graph that we've been working on. Let's recap what we've done so far. The +3 d value, the 2 a value affected our y coordinates. Normally the middle is 0. We used the +3 to find our new middle. We used the 2 to find our new a value or amplitude. 3 plus 2 is 5, 3 minus 2 is 1. This is going to be the top, the middle, and the bottom of our wave. Then we needed our 5x values. Normally we start at 0. We used the horizontal shift to find our new starting point. We went to the left pi, so we're beginning at negative pi. We then found the period to be 2 pi over b. The period was pi. That's the distance between the start and the end of one cycle. Add pi to negative pi, and we get an ending point of 0. We then took the averages of those numbers, negative pi and 0, negative pi and negative pi over 2, negative pi over 2 and 0, to find our 3 middle x values. Last but not least, let's think of the shape of the positive sine graph. There is no negative out front here, so we're just going to go middle, top, middle, bottom, middle. That is one cycle of this sine graph. This is about as hard as we can make it. We gave you a d, c, b, and a value. We need to make adjustments to the y value, to the x values, and we should be good. Okay? The amplitude of a sine or a cosine graph matches the absolute value of a. Amplitude will always be positive. Even if this was a negative 2, our amplitude is 2. We already found our period. The domain of any sine or cosine graph will be all real numbers because even though we only graph one cycle, it will continue on forever. The range from the bottom to the top of the wave. This would give us 100%, for example 1, if we were to submit this to a teacher. All right. So, last final recap. Find the y values using the vertical shift and our a value, which you can consider the amplitude or the vertical stretch, if you will. We find the 5x values by using our horizontal shift, and the b value, which could change the period of the graph, the distance from the start to the end. We then remember the shape of our graph. Sine and cosine, if it's reflected, we've given you that as well. We used the +3 and the vertical stretch to find our y values. We used the shift of left pi and our new period of pi to find the x values. We remembered the shape of the sine graph. We'll do a part B video where we graph tangent.